In this video, I want to do this partial fraction decomposition of x plus 21 over x squared plus 2x minus 15. So when we're doing a partial fraction decomposition, we want to factor the denominator here. So I'm going to factor that. I'm going to get x plus 21 over, and when we're factoring that trinomial, what I want two numbers that multiply to a negative 15 and add up to a positive 2. So that's going to be positive 5 times negative 3, because 5 times negative 3 is negative 15. 5 plus negative 3 is positive 2. So that's going to factor to x plus 5 times x minus 3. Okay. Next, since we have these two factors, we want to set it up like this. So I'm going to say x plus 21 over x plus 5 times x minus 3 is equal to a over x plus 5 plus b over x minus 3. So now what happens then is I'm going to multiply by the LCD. And the LCD is going to be the x plus 5 times the x minus 3. So I'm going to multiply both sides by the x plus 5 and the x minus 3. And the reason I did a and b is because we have x plus 5 and x minus 3. If I have 3 terms, then I'm going to need a, b, c. But I just have 2 terms, so I just have a and b. All right, then I'm going to multiply this side by that LCD also. So let me put this in parentheses. X plus 5 times x minus 3. On the left side, what happens is everything just cancels out, right? X plus 5s, x minus 3s, and we're left with just x plus 21 equals. Then on the right side, when I distribute this x plus 5, x minus 3 into here, what is going to happen with the a part? The x plus 5s are going to cancel on the a term. So I'm going to have a times x minus 3 plus, and then on the next term, the x minus 3s are going to cancel this time. So let me just write this out once. I'm trying to keep this from being just like a jumble of letters and numbers and everything. So when I multiply that out, I'm going to have a times x plus 5. And when I distribute, it's going to be x plus 5 times x minus 3. So what happens is the x plus 5s cancel out, leaving me with just a times x minus 3. But then we do the same thing. We still have to distribute the LCD of x plus 5 and x minus 3 to the b term. So just the same thing happens, but it's just b over x minus 3 times x plus 5 times x minus 3. So the x minus 3s are going to cancel out at that time, leaving us with b times x plus 5. From here, I'm going to distribute the a and the b. So I'll have x plus 21 equals ax minus 3a plus bx plus 5b. I feel pretty good about what I've seen with partial fractions when I've taught this before is people do okay up to this point. It's this next step where you're like, I'm not sure where to go. Like, how do I get the next sentence? Like, where do I go? I know I have to set up some sort of system, but I don't know what the system is. Here's how we go about the next step. You see how we have an ax and a bx? Let's get those together. And you see how we have a negative 3a plus 5b? Let's get those together. So I'm going to have x plus 21 equals ax plus bx minus 3a plus 5b. So then from here, we can factor out the x from that term. So x plus 21 equals x times a plus b, or a plus bx. It doesn't matter where you put the x. And then we just have minus 3a plus 5b here. So now we start matching. On the left side, we have this 1x. And on the right side, we have a plus bx. And on this side, we have 21. And this side, we just have these constants of negative 3a plus 5b. So what this tells us then is that since I have the 1x and the a plus bx, I'm going to set a plus b equal to 1. So I'm taking the coefficient on the x and matching it up with the coefficient on this x. So that's 1. And then I'm going to do the same thing with the constants. I have negative 3a plus 5b. So I'm going to say negative 3a plus 5b is equal to 21 then, the constants here. Let me just make sure I didn't write the problem down wrong. No, okay. Just want to make sure I didn't mess up a number here. So we have a plus b equals 1, and then negative 3a plus 5b equals 21. And then I hope you saw that there. So negative 3a plus 5b, this does not have a variable with it. So these are just constants, and I'm going to use that other constant there on the left side. So I'm taking negative 3a plus 5b, set equal to 21. Now it's just solving a system. If you can get to that difficult part of creating the system, you should have the ability to solve a system of equations, and that's all we're doing here. So I'm going to subtract b from both sides, so I get a equals 1 minus b. I'm going to substitute an a into my second equation, so negative 3 times 1 minus b plus 5b equals 21. Negative 3 times 1 is negative 3. Negative 3 times negative b is 3b plus 5b equals 21. Continue to solve. 3b plus 5b is 8b. And I'm going to knock out 2 steps here. I'm going to add 3 over because that's a constant, so it's got to go with that 21. 21 plus 3 is 24. Divide by 8. B equals 3. Okay. So we have our b equal to 3. Now we need to get a, so that's an easy substitution back into here. So that's going to be a is equal to 1 minus 3. A equals 1 minus 3 is negative 2. So there's our a. So we have our a, we have our b. So the partial fraction decomposition is going to be a over x plus 5. So that's negative 2. So negative 2 over x plus 5 plus b over x minus 3. So plus b, which is 3, over x minus 3. So that's how I would go about writing it. If you flipped it, 3 over x minus 3 minus 2 over x plus 5, that's fine. But I would just write it like that based on how I did it. But there it is. There's the partial fraction decomposition of that. So partial fractions are fun. These really are fun. It's a really good skill to know how to go through this process because it is a very useful process. So hopefully this helped you out with partial fractions.